Hello everybody and welcome to Building with Java on PowerChain episode 1. I am Edy Haddad, co-founder and CTO of PWR Labs. Today we're going to be going over the basics of developing a Java application on top of the PowerChain. We're going to be building a very simple messaging application just to get you familiar with the basics of development on PowerChain. So to get started, I first want to discuss what PowerChain is, and to do that I'm first going to very simply explain what a blockchain is. A blockchain in its basic form is a distributed database. It's often good against corruption and good for data storage in general. However, in its decentralized form, the way we've been utilizing it in the crypto space for the past decade or more, it becomes like a force of nature. It is a fully distributed, transparent, immutable, and secure database. You cannot cheat it, you cannot fake it, you cannot ignore it, you cannot mess with it. It becomes like a force of nature that we utilize for stuff like cryptocurrencies, decentralized financial applications, trading marketplaces, and much more. Now with PowerChain, the PowerChain is a blockchain that focuses on all of that. It focuses on heightened security, global scalability, cost effectiveness for transactions on the PowerChain, because when you send it data, you send it in a transaction on a blockchain, and most importantly, unbound development flexibility. PowerChain is the first ever blockchain where you can build using any coding language you want and any framework you want, however you want. So with that in mind, I have this behind me. I'm just gonna very quickly explain it. So in a blockchain, and in PowerChain specifically, when you build an application, you don't need to have your own server. Users send their transactions directly to the PowerChain. They send their data directly to this blockchain, and then from this blockchain, you retrieve that data and send it to your application and virtual machine. So you have no need for a database. You don't need to run your own server. You don't need to do anything from your side. All you need to do is build the application, and the blockchain, the PowerChain, is the connecting layer for all these users. It's your database, it's your server, it's almost everything. And this is what we'll be doing in this messaging application. So over here, I've already created my Java project. Feel free to create it in IntelliJ, Eclipse, whatever suits you. And in here, I've imported the PWRJ library. So PWRJ is a very helpful tool to building on the PowerChain. We also have PowerJS, PowerPython upcoming, and PowerRust. We're creating Power libraries for all coding languages. You can find more about the PWRJ library on our GitHub. So over here, you can see how to import PWRJ onto Maven or on Gradle, so whichever you prefer. I'm a Maven guy, so I have it over here on Maven. So I'm gonna quickly build my project. I've already built it, but I'm just gonna rebuild it over here, reload the project to install all the dependencies. And for this chatting application, it's a very simple chatting application. We only need two classes. The main class, where we're gonna be creating user wallets and sending transactions to the PowerChain, and the listener class, where we're just going to be reading those transactions from the PowerChain and outputting them on the user's screen. So just a small note to all people who are not very familiar with blockchain. On a blockchain, all users have wallets, okay? And when they send a transaction to the blockchain, they have to pay a small transaction fee. On PowerChain, this transaction fee is very, very low. So they pay about $0.00001, or its equivalent in PowerCoin. So it's a very low transaction fee that users pay because they're storing data on the PowerChain, and there's validator nodes that are also validating the data and keeping the blockchain running securely, so they also need to pay them. Now, the first step of any application or protocol or virtual machine on the PowerChain is to give it an ID. Okay, so when a user sends a transaction, they include that ID in the transaction, so we can easily tell to which virtual machine or to which application the transactions are meant. So the ID is 8 bytes for any application. So in Java, it's a long variable. You can generate it randomly. Right now, what I'm going to do is I'm going to input one manually on random. So I'm going to have public static application ID, and we're just going to have it 4567. Okay, this will be our application ID. It can be anything. It can even be a negative number. It is no problem as long as it's an 8-byte variable. Next, let's create our main function. So the second step of any PowerChain application is to define your RPC node. An RPC node is a server that has a full copy of the chain and can return data to you when you ask for it, so you can read from it, and you can also use it to write to the blockchain, so you can send the transactions through it. So we have a public RPC node that you can use. It's also found over here in the documentation. So to do that, this is the public RPC node, powerrpc.powerlabs.io. So to simply set it in our application, we have powerj.set RPC node URL, and we set our RPC, and that's it, done. We've set our RPC. Now for this tutorial, we will not be covering how to store wallets and recover them. We will just be generating a random wallet every time we run the application, just for the sake of demonstration. So we're going to create a Power wallet. We're going to name it wallet, and in here, if you're an advanced developer or you're recovering a wallet, you can specify your private key. But in here, we're just going to make it randomly generate a private key for us. Okay, so when we don't specify, it randomly generates for us. Okay, so now we have our wallet. Let's output the address of this wallet. So wallet.getAddress, and all of this comes in the PWRJ library. You don't have to do anything additional. So it's as simple as that. Now let's take the user's input and send it to the blockchain. So over here we're outputting the address because we will grab it and put it in the faucet. So over here we have the Power Faucet, where we can claim 100 power coins for free on testnet, and we will be using those power coins to pay for transaction fees every time we send a message to the blockchain. Now let's capture the message from the user. So first let's initialize our scanner, and while it's true, let's take a message from the user. Okay, now over here we're taking the message from the user. Now to send it to the PowerChain, we need to turn it to a byte array. So the PowerChain itself handles everything in the forms of bits and bytes, which enables its development flexibility. So to simply send data to the PowerChain, it's very simple. All you have to do is, using the user's wallet, we type wallet.send virtual machine data transaction. We specify the application ID and the message, but we have to turn the message to a byte array. So get bytes, and we specify our encoding and decoding algorithm, which is UTF-8. Okay, now we have to also surround this with a try and catch clause. Okay, now when you send such a data transaction, you also get a response from the RPC node. So to capture that response, we simply type response r equal, and this response object, it comes in the PWRJ library. No need to do anything else. Now the transaction might fail in certain scenarios. If our data is invalid, if the formatting is wrong, if there is anything wrong, it can fail. So we can detect if the RPC node accepted it or not by simply typing if r.isSuccess. So in this case, the RPC node will return the transaction hash. Okay, so over here we can have transaction hash, and the transaction hash will be in r.getMessage. So there is get error and get message. Now else, if it wasn't a success, let's output the error. Okay, so if it is a success, it will give us the transaction hash. If not, it will output the error. Okay, now it's that simple. That's it. It is this simple to send a message to the PowerChain. Okay, now over here, after we're done with all that, let's also re-output the arrow for our user to send his other message. And that's it. It's as this simple to send a message or send any data to the PowerChain. Now let's create our listener function. So the listen class, I've already have a comment over here. The listener continuously checks for new blocks and prints the messages sent to the virtual machine or the application. So virtual machine and application, kind of the same thing on the PowerChain, just bit different namings and bit different functionality. In our case, we're building an application. It's a software that runs on top of the PowerChain. Now we can check any block we want. We can check all the way from the first block, block 0, to the latest block. But for the sake of simplicity, over here, we're going to be listening from the latest block. So when we launch our application, we start listening to messages. So public static void, we're going to call our function listen. Okay, we want to run this function in its own separate thread because we want it to run in parallel with the user's input. So I'm just going to use this method, which I like to define very simple one-time threads. You can use any method you want, as long as it runs it in its own threads. Now in here, we want to first capture the latest block number. So we have long block number equals PWRJ.get latest block number. Okay, we also need to surround all of this with a try and a catch block. Okay, now we have the latest block number. Now we want, in an infinite loop, to check for the latest block numbers or new latest block number. Now if our block number or the block number which is here is our last to check the block number. So if our block number is smaller than the latest block number, it means we have a few blocks to check. So over here we put block, which is a block object that holds all the data regarding the block and all the transactions in it, and PWRJ equals get block by number, and our block number incremented by 1 because this is the one we want to fetch. Now over here we can get all the transactions out of the block and we can put them in a loop to go through them. So on the PowerChain, there's many types of transactions. There's transfer transactions, delegated transactions, join transactions. There's many types of transactions. The one we're interested in right now is only the virtual machine data transaction. Okay, so over here we have for transaction in block.get transactions. And now we want to skip any transactions that are not virtual machine transactions. Okay, so if this transaction is not instance of virtual machine data transaction, we're gonna skip it, continue, we don't really care. Okay, now we want, there can be many virtual machines on the blockchain. So virtual machine application, as I said, same thing, but on the blockchain everything is defined by a virtual machine ID. Okay, so we need to first transform our transaction into a virtual machine data transaction. This way we can extract the application ID from it. So virtual machine dot over here get virtual machine ID. Now before we extract the message and waste our resources, let's first check if this application ID matches ours. So if this transaction is meant for our application. So if application ID not equal main dot application ID, if it's not for our application, we're just gonna skip it. We don't really care about it. If it is, we're gonna extract the message. So byte, let's first call it data before translating it into message, equals, so the server returns the message in hex encoding. So whatever you get, it's a hex encoded string. So we need to decode it. So hex dot decode virtual machine, let me grab this, dot get data. And now we have the byte array of that data, and to translate it to a message, all we have to do is to encode it with UTF-8. So now to output the message, we're gonna say message from, and we're gonna output the address of the sender. We can get that from the transaction itself. So virtual machine the data transaction dot get from, and then we output the message new string, and be sure to include your encoding format just for safety. So we ensure we have the correct encoding. Okay, char set name. Okay, now that's it. This is, let me also, every time this loops, we're just gonna make it sleep for 10 milliseconds for now. It's not a big deal at the moment in this demo application. So what this does is it continuously checks for new blocks, reads any new blocks, and extracts any transactions meant to our virtual machine. Now we also need to call the listen function from the main class, so I like to put it over here. Listener, excuse me, listener.listen, and now we're listening for any new transactions. Now our application is done. It is that simple. Building a messaging application on the PowerChain is that simple. Now this is not a peer-to-peer messaging. It's more of a global chat room that anyone can access, anyone can chat on, and anyone can access. I've already said access. So let's run it now. It will create our user's wallet and give us their address. Now before we can send messages, we need to put some power coins into this address to pay for transaction fees. So you go to the faucet, you have Power Faucet, this is for developing on the PowerChain itself, and the EVM Faucet, this is for the Ethereum external virtual machine deployed on top of it. It's irrelevant for this tutorial. The only thing we need right now is the Power Faucet. So we claim our power coins, and you can check your transaction on the Power Explorer. So if I reload, yes, it was already claimed 19 seconds ago. As we can see, 100 power was transferred to our address. Now if I type a message, for example, hello, it's going to return my transaction hash, and my message, almost very fast, it is outputted after it. So even though this is a blockchain, processing of blocks and transactions on it is done very fast. So we can see my transaction hash was sent, and less than a second later, my message was on the blockchain and outputted on my system. So if I go to the Explorer, I can also see it over here. So this was my claiming power transaction, and this was my message transaction, and we can see it was sent to virtual machine 4567. This is ours, 4567. And if I open this transaction, I can also see the hex encoded format of this transaction. And this transaction, sending this message, cost me only $0.000083. So the cost is nothing on the PowerChain. And the beautiful thing about it, if right now I compile this application and run two of this client, so I will have two users chatting with each other. So I'm just gonna go over here. One second. Okay, I forgot to define my build configuration. So I'm just gonna open one of my previous projects, go to POM, and I like to use, I use this build configuration across all my projects. You are used to build your application however you want, use any build configuration. It's not a big issue. This is the one I like to use. So Maven clean package. So over here we have our application. I'm just going to rename it to C, so it's easier to type. So cmd java jar c.jar. Now I have two chatting applications running. One over here, so let me close this. One over here and one in my terminal. Now let's claim some power coins to this one. Claim. And that's it. If we go back to the Power Explorer, already done, we've already got our power coins, everything is very fast. So, and if we open over here, if I send, hello, this is Edy. Okay, my transaction hash is here, and we've got the message on both of the users. So the beautiful thing about this chatting application is there is no central server. There is no need for you as a developer to run any server. There is no need to have any database. There is no need to have any connecting point, and you're not limited to one connecting point. On the PowerChain, there's many validator nodes, and there's many RPC nodes. So the users can connect your application from anywhere around the world using any provider they want, using anything they want. It is that easy. So let's reply now to our friend over there. So, hello, this is Edy's friend. Okay, this is our transaction hash, and the message is already here. So it's relatively fast, even for a blockchain, very fast for a blockchain. So it's this simple to build a global messaging application as a developer without any servers, any databases, or anything. And as you can see, the whole thing, if we combine it together, was 46 by 38, so barely 85 lines of code. It is that simple. The PWRJ library provides the tools to allow you to simply develop anything on top of the PowerChain. Now in the future, we're going to be delving into more and more details on how we can have different types of transactions inside of our application, because in this case, we only have one type of transaction, which is a message. Everything sent to our virtual machine is interpreted as a message. In the next tutorial, we're going to be interpreting other types of transactions. We're going to be setting users' usernames. So instead of showing a very long address over here, we show a username. We're going to be adding gifts inside the chatting application so users can send each other gifts, and other types of transactions as well to get you familiar with how to have different types of interactions within your application. In further tutorials, we're going to be going more and more advanced and showing certain features that the PowerChain enables that other blockchains cannot, such as automated execution, high computational processing, hashing and encryption using any algorithm we want, and many more. So all of this code will be on our GitHub, and you can find the links for everything in our description. The link for the GitHub, the Faucet, the Explorer, and even the PWRJ library will be in the description. If you need any assistance at all, you can join our Discord server. We are available almost all the time over there, and we can give you direct assistance in Java, JavaScript, and any other library we support. I hope to see many developers on there, because we have a lot planned for the future for our developer community, grants, hackathons. The PowerChain even has a built-in revenue model. So whenever a user sends a transaction to your application, you actually get a cut of that transaction. So long story short, this will be discussed more in the future, but I hope to see many developers on our Discord server and much development happening on the PowerChain. Yalla, have a good day everyone.